Welcome, folks, to this session on dive into GenAI and Agentic AI best practices for security and observability. This is session BRK OBS 1011. Just checking that you're in the right room. If you're not in the right room, it's okay to step up and step out. It's totally cool with me. Okay, my name is Lipyeow Lim. I'm a Senior Director of AI Toolkit Engineering at Splunk. And my co-speaker, Vedant, he is a Director of AI Core Engineering at Splunk. So he's my partner in crime, kind of building some of the AI features and products at Splunk. And just a quick intro of myself. I've been at Splunk for about almost coming to 2 years. And prior to Splunk, I was at Databricks. I was go-to-market lead for cybersecurity at Databricks. Prior to Databricks, I was at Mandiant. I was an engineering leader at Mandiant and helped build out some of the threat hunting systems that is used by the Mandiant SOC for the MDR business, the managed defense business at Mandiant. Prior to Mandiant, I was a professor for 10 years, working on various big data as well as deep learning type problems. Before that, I was at IBM, was a research scientist. I worked on IBM DB2. Probably if you run DB2 today, some of my code is still in there as well. You're probably still running some of the code that's in the query optimizer. Was also involved in some of the Infosphere Streams product at IBM as well. So this is briefly my background, and now I'm going to hand over to Vedant. Why don't you introduce yourself?
Hi, my name is Vedant. As Lipyeow said, I lead the AI core engineering organization at Splunk. So my teams pretty much focus on applied research as well as applied engineering. So we, again, build the assistants, agents that you see inside Splunk across security, observability, as well as data platform. So we're working on all sorts of problems, again, from assistants, agents, fine-tuning, you name it. And not just that, we also work on classical ML. We work a lot with time series data. And also LLM for time series. But we won't talk about classical ML. We'll stick to GenAI today. Specifically agents and how agents and GenAI in general is impacting security, cybersecurity, and observability. A bit about myself. Before Splunk, I spent quite some time at different startups, including NLP startups. So I was doing NLP before NLP became cool, before Transformers and some of these other models came out. Started my career at Microsoft. If you've had the unfortunate luck of using Windows 10, you probably used my code. Worked on the Windows 10 release. And again, I worked at, different startups in, the AI space. So that's a bit about me. Lipyeow?
Awesome. And by the way, if you're wondering, what does his team do, what does my team do? So he does all the cool stuff. My team kind of helps support his team with all the common AI tooling, the LLM services, the vector DB services, the GPU infrastructure, kind of the more boring stuff, if you will. But we'll get to that. We'll get to that. So a little bit of housekeeping stuff. This is the obligatory housekeeping slide on WebEx. Install the Cisco Live mobile app. If you want to chat with us, you can kind of get onto, there's a WebEx space for this session where we have moderators as well. And myself and Vedant, we're both going to be on it. We're on it right now, but we won't be responding right now, obviously. But afterwards, we can continue to interact that way if you would like. OK, before we go to the agenda, actually, let me ask Vedant a question. Vedant, are you using GenAI today in your daily life?
Pretty much. I think everyone does at this point. I do as well. Pretty much any documentation that I need to write, pretty much I start with a skeleton generated by pretty much any large language model. Now I think vibe coding is a thing. Pretty much all the projects that were in the graveyard have come back online. Everyone's working on those, building those. So I've been doing some similar stuff, again, building agents from scratch. Though I don't put code in production, I think all our software is pretty secure, but it's just general coding from time to time. So that's something I've been using GenAI quite frequently for.
Awesome. For myself, I've experimented with the GenAI stuff. I actually did some vibe coding stuff. I actually put in fact, I put a prompt into Claude once. I asked it to actually write a chat app using LangGraph with the reflection thing, where you actually had an LLM to kind of check on the generation of the first LLM. just to make sure the results are good. And it generated the code. I ran it locally. It was using Ollama. And the first time I ran it, it didn't run. There was an error. So I put in the error into the LLM, asked it to fix it, came back, tried to run the code, still one more error, different error. Ask it to fix it. So about 2 or 3 times, 2 or 3 fixings, if you will, it actually did run. So that was actually pretty cool. Although it did hallucinate too, by the way, right? It told me that, oh, I've disabled this particular parameter in the code, and I went to look at the code. No, it did not. So it is pretty impressive, but I think you do have to kind of check what's going on in it, right? And then in other parts of my life, yes, I've been, as Vedant has said, I use LLMs for a lot of brainstorming, actually. I actually ask it to hey, tell me about this. Hey, I'm thinking of creating a slide on this. Tell me what I should do. What are some of the factors I should consider? And brainstorming is pretty good. And there was one time, my boss asked me, oh, we need a new name for one of your teams. Okay. So I should put in and say, hey, my team does this. We want a new name for our team. Give me some options. It actually gives you some pretty good ideas, and you kind of iterate on it. It's actually pretty cool. And then I think on a personal side, a couple of months ago, my daughter was applying for college, right? And so she had a college essay. And she came to me and said, Dad, can you look over my college essay? And I said, it's too much work. So I put it into LLM and say, hey, my daughter is writing a college essay. I cut and paste the text in and say, give me some feedback. And it actually gave you some pretty good feedback. And then I actually asked it, can you rewrite the essay based on those feedback? And she did it. And it was pretty darn good. However, the irony is my daughter freaks out about kind of AI-generated essays. So I say, no. I can't use that. I got to un-AI. I got to make it sound not like an AI, because it sounds too much like an AI. So she actually took quite a bit of time to go rewrite it so that it doesn't sound like AI. So anyway, take that for what's worth, right? Okay, there was enough kind of fun talk. But let's get to business. The agenda for today's talk, right? We did come up with a bunch of topics that we thought could be interesting. But as Vedant and I, we were looking at the list of folks that have registered for this talk. It's a diverse crowd. And it's we thought there's many directions we could go in this conversation. And so we actually had a hard time trying to figure out, should we try to stick to the script, or do we go off script? And so actually, what we would like to do is we would like to make this very interactive. Feel free to ask questions anytime. Just raise your hands. And we would really like to take this in any direction, in a direction that's most useful for you. So maybe let's start with a quick poll of the folks here. By a show of hands, how many of you are security practitioners? This includes C-suites, like CISOs and whatnot. Awesome, thank you. How many of you are kind of IT ops, DevOps, network ops practitioners? Show of hands. Okay. How many of you are AI app developers? Show of hands. Oh, interesting. No. Okay, awesome. We will keep this definitely a lot more practitioner-oriented then. And then feel free to ask questions of us. So a bunch of topics that we could go into, and for each of these topics, we can go either a much more practitioner-oriented slant or more kind of developer-oriented slant, depending on how things go. So AI is changing how we work. We already touched on that a little bit. We'll talk a bit more. We'll look at AI assistants and agents, frameworks and protocols, hallucinations. I mean, you all heard about hallucinations, quality, performance, privacy, and safety. Okay? So let me start with this quote. This is something that Cisco's Chief Product Officer, Jitu Patel, said at RSA. This is a couple of months ago, right? Today, 100% of our workforce is humans. But tomorrow we'll have a huge augmentation of robots, of AI agents, of humanoids, of AI apps. It was just at RSA in April. Okay, so what does this mean for us, right? And maybe I might pose that question to Vedant. Vedant, what do you think? What does this mean for observability, for like DevOps, SREs, practitioners?
I think if you look at it, the way AI or GenAI is progressing, maybe till about a year back, we were thinking about assistance or assisted operations, where you could help SREs, DevOps, identify issues, find the root cause, troubleshoot it, and then resolve it. Now we've moved on to agentic workflows, where we want this to happen in an autonomous manner. So I think as the technology evolves, I think the DevOps, SRE roles, I think those are going to evolve as well, where some of this, the low-level tasks will be done in an autonomous manner, while folks can focus on some of the more critical and important items. So Lipyeow, what do you think about security operations? How would that impact security?
Yeah, so I think for security, it's an interesting space. I know most SOCs tends to be conservative, but I do see that AI is really penetrating into the SOC, and lots of SOC actually considering using AI. And for various things, I think the low-hanging fruit is more on kind of the read-only type stuff, like, hey, can you summarize alerts? Can you recommend investigative steps? How do I investigate this alert? How do I triage this alert? And probably kind of recommend playbooks. Although I think we are seeing that folks are getting open to the response steps as well, and actually letting the agents take a little bit of autonomy to try and do some additional triaging steps or response steps. So, but for certain, I think this AI is definitely disrupting the whole security space as well. And with that, actually, Dan and I, we have been at Splunk in the last maybe 2 years. We have been building out our Splunk capabilities in terms of AI, AI assistants and AI agents. And in fact, I'm going to just quickly show you that this is we have a security agent that's in preview right now, but it's coming out, and it's actually going to accelerate security operations. As you see here, you can sort of put in and sort of ask for investigation steps, and it will actually spit out a whole bunch of investigation steps that could help you, right? Oh, sorry, that was summarized finding. This is the loop actually, right? And so this is something that we showed actually. This is actually a demo from last conf. There's a video of it, and this is for the security side. Vedant, you want to talk about the observability side?
So yeah, similar to security, we've launched something called an observability assistant. It's in GA now. So it helps troubleshoot issues. So you've seen an alert. You want to know why something's gone wrong. You can just give it a command. You can ask, hey, this node has gone down. Can you look into why something's gone down? And it's going to, again, make different tool calls, identify different logs, look into different logs, metrics, and then give you information as to why something's gone wrong. And then if you ask for a recommendation as to how do you resolve it, it's going to give you some recommendation steps. So again, this is in production right now. It's in GA. Anyone, if you are interested, you can go take a look at it. And I think there's a separate session which covers Observability Assistant in detail. I think it's on Wednesday. If you're interested, you can attend that one as well.
Awesome. Another quick poll, right? How many of you in your organization, whether it's for your SOC or for your IT ops, how many of your organizations are really using some form of AI assistant within its operations? Just a quick show. Okay. Maybe, looks like maybe about 1/5, 20% of the crowd.
Well, what about agents? Is anyone using agents in production? No?
Yeah, I think that's a good question. That's a good question. You have a question? Okay. Yeah. Let me get to that. Okay. So let me get to that in the next slide.
Lipyeow's got a question.
Oh, yes, please.
Two questions. Maybe you know, maybe you don't. But first question is, what do you use in your toolbox when you're working in AI? Right. And two, are you going to go over how you got here? Like, do you go from scratch? Like, you're involved in everything? Or, like, somebody's created a model and said, here's your model, and here's what you're going to use when you develop it.
Yes.
from there.
That's a great question. Actually, I know we'll get to it, but actually I think it's worthwhile to maybe talk a little bit about that here. And Vedant, you might be the best person to talk about the journey we took from, for our SPL assistant, for example. We actually released that quite a while ago. The first version is very simple, and it's kind of evolved. So you want to kind of say a couple of things about that?
I think, again, as we all know, GenAI has evolved quite a bit in the last 2 years. When we started working on this assistant, this was our very first assistant called SPL Assistant. So in case you don't know Splunk has its own query language called SPL, Splunk Processing Language. So to use Splunk, you need to know that language. It helps you search for data, it helps you analyze data, and it helps you visualize data. So the way we started with SPL Assistant was 2 years back, we started with a very simple model called T5. We trained it on a bunch of SPL queries, human labeled, generated it, did not work most of the times. We compared it to GPT, it was pretty much doing the same thing, roughly. Then what we saw was we need to do more. There is no other company or no other person or entity that knows SPL better than Splunk does because it's our language, right? We tried to, again, get more data. That was one, get more labeled data. That's always one of the solutions. Then we created something called a knowledge base for RAG, which had, again, a bunch of curated SPL queries, which work for most of the cases for any given customer. Again, I'm not sure if you know Splunk too well, but it's a very flexible platform where you do not have to define a particular schema. So your schema is schema on read. So you can pretty much pump any data into Splunk. So it has a lot of flexibility. What we saw was generating a simple SPL is not good enough. What you need to do is you need to customize or personalize your SPL for a given customer or a given stack. So then we put in some kind of personalization element into it. Even with RAG, we had to do different kinds of innovation when it comes to data retrieval. So it's not as simple as, hey, you just create a semantic embedding, and it's going to pull some information, and you just pass it to an LLM. We actually innovated, came up with some kind of research. We published a paper as well on that, which helps us extract information in a more capable manner for our use case. So we did that as well. Beyond that, we've also done fine-tuning now. As and when new models came out, we've, again, fine-tuned some of these large language models. Again, I think now you have an option of either using closed-source frontier models, or you can use some of these open-source models for your use case. So depending on what the use case is, in this case, we've fine-tuned a model based on our data. So again, there are different things that go into, again, developing this end-to-end solution. And those are some of the things that we've tried to do over time. And that's just a part of it. And we will cover more.
Yep, we have another slide on kind of choice of models, which we'll hopefully get to. But to get back to this gentleman's question about what is agentic systems, I've actually thought of this in terms of a continuum, right? So on the left side, you have what I'm just calling the assistants, and on the right side, the agents, right? On the assistants side of the continuum, it's, again, much less autonomy, much more reactive, and there's sort of a constant user involvement. Like the user has to keep asking questions, right? Keep prompting it, right? And then on the right side, where it's kind of more fully autonomous agents, right? It's the agent's doing almost everything by itself. Therefore, it's actually much more proactive. And from the human interaction point of view, you're just giving the agent some high-level goal, and it will actually go and actually perform it. Now, of course, I think most apps today are somewhere in between. I don't think we're at the fully autonomous side. I mean, folks are exploring that, but I think in production, probably less so. And for example, also when we heard about Vedant talk about the SPL assistant, right? It started out as something that is very, very much limited autonomy and much more, user prompting, more like single prompt kind of thing. But in fact, today, even the SPL assistant is much more agentic underneath the covers. There's actually multiple steps and multiple LLM calls to different LLMs underneath the covers, right? Before it actually generates the final SPL. So even something that looks like an assistant is getting more and more agentic underneath the covers, right? So this is why it's actually quite difficult to actually pinpoint what is truly agentic and what is not. They all exist in a continuum. Okay, awesome. Just going to go one more slide, and then we can have more questions. Since this whole topic of agents, you probably heard about frameworks and protocols. Frameworks are things like LangGraph, AutoGen, Llama Index. LangGraph, for example, gives you a lot of control over the state of the workflow. And it can also integrate with other protocols like MCP and A2A, right? LangGraph is open source, but it's definitely very developer-centric. But why is this relevant to you? I'll get to that, but let me get to protocol. You probably heard of MCP. MCP is kind of taking the world by storm in many ways. Everyone is talking about MCP. Everyone's kind of releasing some kind of an MCP server. But it really is a tool of data integration protocol. And it's used by other frameworks. It's community-driven. It's LLM agnostic in the sense you can use it with any LLM. Right? Even though I think some LLMs are better at it than others, right? And there's also A2A from Google, right? This is more around agent collaboration, like one agent talking to another agent to collaborate on a particular task as well. Somewhat a bit more enterprise focused. You may have heard of Cisco Agency. It was kind of proposed by Cisco, but it's actually consortium-led, right? So this is talked about an internet of agents, and it leverages MCP and A2A as well. And this is an emerging standard that's happening right now. Now, why is this? Well, first of all, if you have experimented with MCP, right, it is pretty powerful, right? If you have tried, say, Claude Desktop, you hook it up to an MCP server to either your file system or to Google Drive or to your GitHub, or even to Splunk itself, or to Kubernetes if you're SRE, right? It's pretty darn powerful. You can do some really, really cool stuff and cool troubleshooting steps. And it's, it may not be production ready, but there's definitely a lot of potential. And then for the security folks, I think the interesting things here is that as we get more and more into the agent space, right, there's more autonomy. These agents have more autonomy. What this means is that your agents become like a additional attack surface, right? And it's like we need to do threat modeling. I don't think we fully understand how to do that. We need also like authentication and authorization for these agents as well, because it is able to execute potentially arbitrary code, right, within your parameter. So there's lots of interesting stuff, interesting open problems here. Potential is huge, but there's lots of unknowns as well. So maybe I'll kind of pause here. Maybe quick question, is anyone using MCP servers in your organization today? One. Okay, cool. Any questions, any thoughts and questions around frameworks and MCP servers and agency? Okay, otherwise, I'm going to let Vedant talk about choosing the right LLM for your AI capability.
Cool. Thank you. So I think all of us use different kinds of large language models. Some uses OpenAI, Claude, you have open source models. Now, which one is the best, or which one should you use? Again, the answer is it depends on what are you trying to achieve. So when you're building, say, an assistant or an agent, maybe one model is not enough. You have to use different models for different tasks. And the number one thing that you need to consider while selecting a model is performance. What is the task? What are you trying to achieve? How good should it be? Particularly if you look at the security use case, the scope for getting things wrong in most of the tasks that a security analyst performs is very low. You cannot get things wrong. You want the best performance from your system. So that's one thing to consider. And depending on the task that you're trying to perform, say, for example, if you're just doing a summarization of an investigation or an incident, the scope of getting things wrong is a bit lower compared to, say, you're asking for triaging steps or you're asking the agent to triage and resolve a security issue. At that point of time, you need peak performance where things cannot go wrong. If things go wrong, there's a lot at stake. So model performance is a very key criteria when it comes to model selection. The second thing that we need to consider is latency. With bigger models comes more latency. Now, depending on, the task you're trying to perform, if you need quick response, you need to use a smaller model in a lot of the cases. You cannot use bigger models. Now, the question would be, hey, smaller model, low performance. There are different ways to, again, mitigate that. One, you can use either specialized model. Say, if you're working in the security space, have a security-specific or foundational model which is focused on security. Or you provide the right kind of context to your large language models. So you make sure you're using a smaller model, the latency is low, but the quality is still there. The other thing you need to consider is, again, the cost. Again, more models coming out, larger models coming out, they're more costly. I don't know if you've played with reasoning models take a lot of compute. They'll take a lot of time to execute, process, and then give you the output. So those are expensive in general. So you cannot use those for pretty much all tasks. So again, coming back to the incident response or incident report. If you're generating a report, you don't want to use a massive model which has to do some kind of reasoning because the data is there, you're just trying to summarize it. There's no point of reasoning or trying to understand what's going on and then coming up with a summary. But again, if you're trying to come up with a SOAR playbook, at that point of time, you actually need to reason. You need to figure out what are the different components that I have available to me and then come up with a playbook. So it's very different depending on the use case. You have to choose your different models. Then again, context window, this is like these days, this is not really a problem. Most of the models have very long context window. For those of y'all who don't know what context window is, it is the amount of data that you can pass on to a large language model. So these days, it's not really a problem, but that's something to consider as well. And then I think the other thing is integration. What kind of support is available? Now, if you're using some of these frontier models, closed source models, you have APIs. But again, if you're using, say, an open source model, you have to host it on your infrastructure, make sure you are able to scale. It's supported. You have to look at the latency. You have to look at the right kind of GPU support for those models. So again, that's something to consider. And we've, again, worked with a lot of security customers for a security assistant. Something that we've repeatedly heard from security customers is, hey, we have a lot of sensitive information that we cannot send to these third-party model providers. We want Splunk-hosted LLMs where we can just pass in information and my data secure, it's within the same compliance boundary. So that's, again, something that we've looked at, we've heard from customers, and particularly, personally, at Splunk, what we do is we have Splunk-hosted LLMs, again, trained, tuned on our data. In fact, recently, Cisco's foundation team, we launched a security-specific foundation model. If you've not checked it out, please do. So that's, again, something that we do in our security use case. Now, how do you go about building some of these capabilities? So we typically, again, the best way to prototype or quickly get a solution out of the door is you build a prototype with a larger model because it's seen more data. It's going to respond better given whatever limited context or domain that you're working with. Again, given the security context. If you're working on a security problem, even though it might not have seen too much security data, it'll still have a better understanding. So comparing Llama 70B to an 8B model, a 70B model would have seen a lot more security-specific data. So if you want to come up with a prototype, just use that quickly and just get going. And then depending on the kind of task, again, you'll have to use a different kind of model. As I said, for some cases, you'll have to use a reasoning model. I gave an example about SQL generation, code query generation. For that, you'll need some kind of coding-specific language. So we've tried different kinds of languages like models like StarCoder, CodeLlama, and recently we've got our own model. So again, you have to use different kinds of models for different use cases. So that kind of covers task specialization as well. Like again, security-specific models if you want to use security or work in security. Multimodal, we don't work a lot with multimodal. For us, multimodal is a bit different. We work with, for us, multimodal is metrics, events, logs, and traces. Because we are in the security as well as observability space, that's the kind of data we work with. We don't really work with multimedia or like videos, audio. But that's, again, something that you need to consider if you want to work in that space or if you want to build an app in that space. Cool. So I think we've heard this term hallucination quite a bit. And this is something pretty common. Everyone just says, hey, something's gone wrong. Hey, this is hallucination. But I want to clarify what is hallucination in general. If you're using an LLM to decide which tool to call or which skill to invoke, that is not hallucination if it gets it wrong. Hallucination is when it makes up information but is extremely confident and is making up information. That's when you see that's what you call hallucination. And it can have big impact on the product or the application that you're using. Again, giving the security example, you're a security analyst. You're using a security assistant, but it's giving you the wrong recommendation repeatedly. At one point of time, you're going to lose trust. And security is a tough space where the stakes are pretty high. You can't get things wrong repeatedly. So getting the trust, getting the security analyst to be able to trust the system, being able to consistently use it is absolutely critical. So you need to do different things to make sure you reduce hallucination across the board. So that's extremely key. And again, it impacts your decision making as well because, again, if you're giving wrong recommendations, you can say, this is a malicious, this is a true positive. You've come across an incident, it's a true positive, you said otherwise. And it led to a major incident. It can have like different issues across the board. So again, you need to be very careful about your recommendations, the kind of quality you have, which I'm going to cover later as well. But that's what hallucination is, and I'm going to talk about next how do we limit hallucination. But first, the contributing factors for hallucination. One of the key contributing factors for hallucination is training data. A lot of the models that are used currently are not domain specific. So again, if we're talking about security, if you're trying to, again, ask for, hey, what's this MITRE attack? Or can you tell me more about this CVE? If the model hasn't been trained on that, or if the CVE is new, it would have never seen it. And at that point of time, it's just going to hallucinate. And it's going to give you like some made up information. And that can be pretty problematic. So again, consider you're creating an investigation report. You've come across a CV, but the model has never seen it. It's going to give you a recommendation that, hey, for this CV, this is what you need to do. And that can lead to all kinds of issues. So training data is absolutely critical. Like if the model hasn't been trained on that, it can have a lot of issues. Next, model complexity. This is, again, something I referred to a bit earlier. When you use larger models, the inherent understanding is it's been trained on a lot more data. It has more weights, has seen more, retains more. So the probability or the likelihood of it getting things wrong is lower compared to a smaller model. So depending on the kind of model that you're using or is powering your security app or observability app, it can get a few things wrong. So again, it's kind of a trade-off which model to use, but larger models or models trained on a particular domain does better for the particular domain. And lack of context. Again, coming back to the CVE or the MITRE attack example, even if your model has not been trained on it, something that we've done in our assistant is we were trying to generate an investigation report. You can't constantly train your model on new CVEs or attacks, right? So you can create a knowledge base of these attacks, CVEs, constantly update it, and prompt your model with this new information. So this limits hallucination, where you're providing the right information to your model to limit, again, limit the model or the system from coming up with new innovative CVEs which actually don't exist. So that's one way to resolve or make sure you're trying to cover your tracks while building this solution. Next slide.
Vedant, question for you, right? So we have mostly practitioners in the room here, right? Given that these folks are not going to be able to fine-tune the model, or maybe they have even less control over what context to provide, what should they do? How should they think about models?
Again, I think a lot depends on the user experience, the way this app has been defined, to be honest. I think, again, if it's an assistant, be more explicit in your prompts. I think that's one way to go about it, where you have to give a lot more information if the underlying system doesn't have that kind of information. So that's something you have to do. Then you'll also have to maybe, again, get feedback. You can ask, again, the developer or whoever's system you're using to incorporate some of this. But I think a lot depends on the user experience and how the app has been designed. So you can actually give some kind of feedback or do something with it. But it's kind of hard if you're just using a system. There's limited things that you can do as such.
Tell your vendors.
Question.
Yeah, if you take all three key factors, are there learning templates that help build, I guess, better quality training for the LLMs?
Yes.
Or you can block out and say, we don't have enough context for this, we're going to block this out so you don't.
Yes. That's absolutely something that we've done as well, where, say, you can consider this as guardrails or in general, I think, filters, where you can specify to the model that, hey, if you would get a request for, say, some malicious attempt or some other information that you don't have, try to ask for more information or just say you don't know. So again, you'll have to kind of build that into your system. So again, it depends on the way the app has been built, but that's definitely one way to. Yes. Absolutely. And that's something we absolutely do in our security assistant product as well.
And that's a great segue to the new slide. Next slide.
Again, strategies to limit hallucination. We've kind of touched upon some of this already. Data curation, quality control. So if you're fine-tuning, training your own models, make sure you have enough clean, labeled data for building that model. So if you're, again, trying to fine-tune or build a foundation model, you'll have to make sure you have enough data, again, security-specific data, so you can, again, fine-tune those models. Next is post-processing, validation. So this is, again, pretty critical and has to be built into the app. So something that we do, again, giving an example from SPL Assistant, we are generating this SPL query, which if you run on a given stack, if it's inefficient, it can cause a lot of issues where you're trying to pull a large amount of data, and Splunk typically charges customers based on the processing time, right? So if you're generating inefficient queries, it's a loss for our customers, gain for Splunk, but that's not a good experience for our customers, right? We don't want that at all. So what we do is when we generate an SPL, you run it through different kinds of parsers, different kinds of checks. So you can do some of those to make sure you're minimizing some of this hallucination or quality issues. So that's something that you can do as well. The other thing is human in the loop. When you're, again, if you look at the security space, as I said, stakes are high, things can go wrong. There are trust issues if you see too many inaccuracies. You want to design experiences where you have human in the loop. You can get feedback. You can ask the human, what does this look like? Is this correct or not? Another thing that you should always do is give explanations wherever possible. That, hey, I think this is the output for so-and-so reason. This helps the end user, again, feel comfortable with the output. If they see inefficiencies or inaccuracies, they understand why the model has made this kind of a decision. So you don't lose your customer right away. So that's, again, another way to make sure you're limiting the impact of hallucination on your user experience. And then finally, I've mentioned this model fine-tuning. We've released a security-specific foundation model. That's something that you can use. And that's particularly built because we've seen constantly that these general-purpose LLMs, they are just not good enough. They've not been trained on security data. They can do a good job for, say, 60, 70% of the cases, but having not seen security data, they just don't do a good job in general for very specific use cases. So again, using security-specific data or observability-specific data models is pretty key to limit hallucination. All right, next slide, quality. This is kind of tied to hallucination. Hallucination is kind of a quality issue, right? But in general, when you look at quality, there are a few things that you need to consider. You want to make sure you have accurate outputs. You have to check against, say, technical metrics as well as business metrics. From the technical standpoint, if you're trying to come up with an SPL query or SPL query, for example, you want to see how efficient is it? Is it giving me the right outputs? And from the business standpoint, you want to see, hey, is this reducing my MTTR, mean time to resolution? So is it doing that or not? So that's, again, something that you need to look at while you're evaluating a system or building a system. Then the robustness. Whether it's working most of the time or not, how many errors are happening? Is it giving you the right output? Are you reaching the, like, for example, if you're talking about agents as such. In agents, what happens is you have a dynamic workflow that is generated, and then it goes in different paths, and then finally gives you a final answer. And in this case, you can get inaccurate results or inconsistent results, which is the third point over here, where you're trying to do the same operation twice, you might get completely different outputs. So you want to make sure your outputs are consistent as much as possible while working with agents. Say, for example, now you've come across, say, your Kubernetes node went down. You want to know why did it go down and how do you remediate it. You've asked the agent, hey, can you look at this? And it looks at 3 or 4 different tools, gives you a solution. But if you ask the agent to perform the same task on a similar issue or pretty much the same issue, it might not go through the same 3 or 4 steps. That's the nature of agents. But that's not necessarily a good thing, because you want the agent to learn constantly from what it's seen in the past. So that's a critical piece that has to be incorporated in agents as well. So consistency in general is super important. Yeah, next slide. Quality evaluation, right? Like, so how do you evaluate the quality of an AI application or an AI system? One, you can do it technically, like there are certain things that we do, things like LLM as a judge. Again, if you are, say, a developer, we've not seen too many hands, but the first one is for a developer. Something that people do generally is LLM as a judge. You ask the LLM to rate a particular skill or a particular output. But a lot of times it doesn't work. The way to make it work is you need to have technical metrics or human-labeled data or human-labeled numbers, which you can then correlate with your LLM, which is a judge. Unless you do the right kind of correlation, a lot of times this does not work. So if you are developing an app, you need to really make sure if you're using LLM as a judge, it correlates to the outputs or the labels or the quality numbers that are generated by humans. That's the best way to trust LLM as a judge whenever you're building it. The other thing is quality is in-product feedback. So something that we've done, again, while developing our AI assistants, agents, is asking the customer to give feedback and using that to improve our models and systems. So pretty typical, I think everyone's looked at DeepSeek and some of these other models. We do something very similar where, again, get feedback and then fine-tuning models. So RLHF, reinforcement learning. So that is another way that we use to improve our systems. And then qualitative evaluation by experts, I think this is something I've mentioned. As we discussed, generative AI can be convincingly wrong. And if you're working in security, on our same example, you've seen an investigation report, you've seen some MITRE attacks or CVEs mentioned, it could be completely wrong, but extremely confidently wrong. So at that point of time, you need to have some of these SMEs, security analysts, actually wetting the outputs, giving feedback on what can go wrong or what is going wrong. So that feedback, we've got our own SGS team, our Security Operations Center. So they are our customer zero. So whenever we come up with a new feature, we make sure they test it, they give us feedback, we iterate on top of it, and then incorporate some of that into our product. So that's another way we try to minimize some of the issues that we see. And finally, the last thing is Agentic Data Simulator. With agents, it's extremely hard to generate end-to-end data to test and evaluate, because agents are somewhat unpredictable, which is what I talked about, where there's lack of consistency. And there's lack of end-to-end data. So one of the things that we've done internally at Splunk is we've created this tool which we call Resilition. I think it's safe to mention it. So what it does is it generates end-to-end logs, metrics, and if we are talking about security, it generates, say for example, findings, alerts, and reports. So it generates all of this end-to-end, which we can then, through our developed agent, see how well do we correlate or how well can we actually map to the golden set that was generated through the agent or this data simulator. So this is, again, something that we've built recently, which helps us, again, improve some of our agents and make sure it's consistent, it's learning from feedback, as well as improving over time. So this is one of the most critical pieces that we've built recently. Yep.
How are you guys overcoming almost convergence or data generation kind of blind spots that tend to form up as more and more models get trained on similar sets of data and other things? It's very similar to groupthink and other stuff associated to it. So we've seen collapse of models and dropping in kind of like they're all starting to see the same set of capabilities, other things that are developing very distinct blind spots in domain-specific models.
That is definitely true for general purpose models, but what we train on is enterprise data, which no one has access to.
Well, no,
so,
I mean, even with the enterprise data sets and the other pieces, like even generating the same set of run books, the same set of pieces, if you have blind spots in your data to start off with, and then you generate using agentic data simulators, it repeats those blind spots. It's
for sure. For sure, absolutely.
Blind spots. What are you guys looking at from that perspective in order to overcome or identify? It's the you have known unknowns and the stuff you don't know, right?
Yeah, no, I actually think that's a great point. And actually, that's also one of the reasons why we created the Agentic Data Simulator, because we're actually worried about the data that's out there. Because everyone is training on the same set of public data that they're crawling from the web, right? So there's a little bit of a groupthink there, if you want to call it. So actually being able to have your own simulator and being able to kind of generate different scenarios, new scenarios, hopefully, I think that's the intent. If you can generate new scenarios, right, that should help break that somewhat. But to your point, there's always going to be unknowns. So I think those are going to be extremely difficult to deal with. I mean, even in security attacks, like there are unknown attacks that we don't know about. Exactly. Yeah.
And I think, again, as you find the gaps, you kind of try to add those scenarios to your simulator, right, to constantly improve and build on top of it. So this provides us flexibility to add more and more wherever necessary, wherever you identify the gaps. So that's also
a great point. Okay, we don't have too much time, so I'm not going to spend too much time on performance, even though this is definitely one of my areas. And by performance, we just talk about quality. So I'm not talking about performance in terms of quality or accuracy. I'm talking about performance in terms of just the regular latencies and kind of throughput and scalability. So in a very similar way to like distributed systems, we have a triangle here of scalability, efficiency, and latency, right? A lot of times for the interactive assistance, you need the latency to be in an acceptable criteria, otherwise the experience is very slow. And then for us, we're kind of serving hundreds and thousands of customers. So it's in some cases, for example, AWS Bedrock, there are some guarantees. But if you want a bit more, you have to go the cloud self-managed route, in which case you'll be standing up your own GPU infrastructure within AWS, running it within your VPC, and then running the LLMs on those GPU instances, right? So this gives you a lot of control, right? And then you have full audit capabilities there. And I would say that for Splunk, for most of our services, we are going this route because most of our customers do not want their data to leave the Splunk compliance boundary. Typically, they don't want us to send their prompts to Bedrock even, or send their prompts to OpenAI, for example, right? Just let me finish this point, I'll get to it. And then just last but not least is kind of on-prem infrastructure for some of our most critical and most conservative or most sensitive customers. They want their LLMs on-prem. They don't want any of the prompts to leave their compliance boundary, right? Think of the big banks. Think of some of the PubSec, some of the federal customers fall into this category. And so this is an area that we are working on as well. We are bringing some of our AI capabilities on-prem so that the customer can host this themselves, even in air-gap environments. So that's something that we are working on. Anyway, to your question, yes?
So my understanding, right, this might be way,
Yeah.
but the costs and time to deploy or production is aligned with.
That's correct.
That's right.
That's correct. The way this chart was created, and thanks for reminding me to explain this, on the x-axis you have sort of the privacy control, like how much control you have over the data, and on the y-axis you have the implementation complexity, which is also closely tied to your cost. So if you see, each of these boxes kind of goes up on the diagonal, right? So the on-premise infrastructure is going to be the most costly as well as the most complex, right? Because you're going to need your own folks to deploy you're going to purchase the hardware infrastructure. You need your own folks to maintain whatever operating system, Kubernetes and whatnot that goes on top of it, and then to be running the LLM serving infrastructure on top of it.
So do you see most customers living in the API cloud?
Yeah, I think most customers are going to live in the first three buckets, but we do have a sizable on-prem customers for Splunk, right? So we have a very sizable chunk of customers there, so we need to serve those folks there as well. Okay, I'm going to actually, since we're kind of at time, I'm going to actually just go straight to our concluding slides. I think we have touched on various things. We have touched on agents versus assistants. We have touched on frameworks, protocols. We have touched on hallucinations. We have touched on how to choose LLMs. We have touched on quality evaluation and a little bit of performance and deployment as well. And we have touched on some of the risks, some of the operational risk around there as well. But we have also seen just within the last year, right, this field is moving so fast. Even though I may have opinions now, and this is one set of opinions, I think things will change. So I think we have to be open to change and not hold too strongly to these opinions. Because we talk about hallucinations, but models will get better. I may remember when GPT first came out, it was crappy, right? But look at GPT today. It's much more amazing compared to the first version, right? And then GPUs continue to get cheaper. Inferencing costs will continue to drop. And I think the best apps are yet to be built, right? With MCP servers, different UX, frameworks, protocols. And then even though we are a little bit scared of full automation, who knows? Who knows? I think we might get to full automation sooner than we think. So strong opinions, loosely held. Thank you, folks.